All right, starting lesson 1.4, working with functions. All right, so what is a function? A function, all right, is an equation that passes the vertical line test. An equation is a function if for every x value, there is a unique corresponding y value. All right, so looking at this first graph here, if you draw vertical lines, wherever you draw a vertical line, all right, it only passes through one point of the graph. That means the graph then is a function. All right, same thing here. Wherever we draw a vertical line, it passes through one point of the graph. All right, so that means it's a function. All right, then there's a couple examples here of graphs that are not functions or equations that are not functions. So here, draw my vertical line, 2 points. You may say, well, what about right here? 1 point. All right, well, that doesn't matter. If there's one spot on the graph where a vertical line passes through more than 1 point, then it's not a function. All right, same deal here. All right, 2 points. Can't be a function. All right, so going on to example 1, which sets of ordered pairs represent functions from A to B? Okay, so we have a set of values for A. All right, these brackets denote set notation. And then we have set B, which is these values. All right, so going from A to B, you could think of the A values as your inputs and the B values as your outputs. All right, relating this back to something that you understand better, the inputs could be thought of as your X values, and you plug them in your equation, and then you get an output, a Y value. That's another way to think about it. All right, but for part A here, we have to determine if this set represents a function. All right, so what does it mean to be a function? All right, so for every X value here, all right, we're using all the X values, all the inputs, there should be a Y value associated with it. All right, and that's what we have here, one Y value. Now the Y values could repeat, all right, that doesn't matter. All right, so this is a function. All right, and you'll understand this better as we go through the examples, because once you understand what's not a function, that really helps you understand the whole concept better. All right, so going to part B, we have all these inputs here. All right, but look at this here. Look at this. This input repeats. And when it repeats, we have two different Y values that it corresponds to. So in that case, it cannot be a function. All right, if you want to make better sense of this, just think of a graph. All right, let's graph these points. 1, -2, and 1, 1. All right, so it doesn't matter what the whole graph looks like. We know that these 2 points that I just graphed are part of the function, if it is a function or equation, and if I draw a vertical line, it passes through these 2 points. So just based on the vertical line test, giving you that visual, you know it's not a function. All right, C. Here are all of my inputs once again. All right, now look at the outputs. They're all the same. All right, now a lot of students say that, no, this is not a function, but it actually is a function. All right, and if you ever get confused, just graph the points. That's all you have to do. So 0, 0, 1, 0, 2, 0, 3, 0. Now, if I apply the vertical line test, every time I do that, it only passes through 1 point, right? So yeah, then it's a function. All right, and for part D, this also tends to be a confusing example for students. Here I have 0, 3, and 1. Okay, now I'm missing one of my inputs. All right, so since I'm missing one of my inputs, then it can't be a function of ordered pairs going from A to B. All right, you have to utilize all of your inputs. So the answer here is no. All right, going to example 2. Determine whether the equation represents y as a function of x. All right, in order to do this, you have to first isolate y. So here I'm going to square root both sides. Don't forget the positive and the negative. So y is equal to positive negative square root of x. Okay, now this is not a function. You know that immediately. Well, why is that? Well, because as soon as I plug in an x value, say, for example, 2, well, how many y values do I get in return? I get 2 y values, all right? And in order for it to be a function, you should only get 1 y value in return. So whenever you have the positive, negative, that's an indication that's not a function. Let's get y by itself. For the next equation, square root both sides. Once again, don't forget the positive and the negative. Y is equal to positive and negative square root of 4 minus x. Okay. So once again, we have the positive and negative case here. It doesn't matter what value of x I plug in, I'm still going to end up with 2 values for y. So, your answer is no then. This cannot be a function. Alrighty, and going on to the next problem. Right away, you should look at the structure of this equation and recognize that this is going to be a circle, and a circle is not a function, because if you apply the vertical line test. Okay, my pen ran out of power, had to recharge it. Okay, so this is the equation of a circle, and this circle will not pass the vertical line test. All right, circle, vertical line test, passes through more than one point. So the answer right away is no. It's not a function. All right, for the last one, we already have y isolated here. There is no positive negative here. I've seen students, actually many students in the past, they see a square root, and since they see a square root, they add the positive and negative to it. Now, if you did not introduce the square root yourself, then you don't include the positive and negative. So make sure not to do that. All right, y is already isolated. So what happens here? For every x value you plug in that works, you'll get 1 y value back. Okay, and in that case, that makes this a function. So for every input, I get 1 output back. Or maybe I'll do this. For every input, I get 1 output back. Alrighty, so the big idea is for every x value, there should be only 1 y value. Or for every input, there is exactly 1 output. Alright, going to the next example. Alright, going over example 3. Evaluate the function at each specified value of the independent variable and simplify. Okay, so some students that aren't familiar with this notation think that we're multiplying here, but this is known as function notation. So I'm taking my function f and I'm evaluating it using the value -8. So in this case, we have x as our variable, and I'm going to be plugging in -8 for x. So wherever I see an x, I plug in -8. So let's do that here. Square root of x, which is -8, plus 8, plus 2. You have square root of -8 plus 8, which is 0, plus 2, which gives you 2. All right, f of 1 here. All right, taking the function f, evaluating it using the value 1. So I take the square root of 1, that's plus 8, plus 2 on the outside. I have square root of 9, plus 2. Then I have 3 plus 2, which is 5. All right, and part C. All right, this particular type of function being evaluated with this value here tends to be a little confusing for students, but this is all you're doing. I'm taking this value and I'm substituting it in for x here. So I have square root of x, which in this case I'm substituting in x minus 8, and it's plus 8 plus 2. So the square root of x minus 8 plus 8, these cancel, so I have x plus 2. And that's it. Going on to the next example. All right, find the domain of the function. Alrighty, this is what you have to do. Since I'm working with an even root here, I can only take an even root of a number that is positive or 0. In other words, this can't be negative, okay? So x squared plus 3x cannot be negative, so it has to be greater than or equal to 0. All right, now if I solve this inequality, I'll figure out what the values of x are, or in other words, what the domain is. So I'm going to factor to start off with. And you could approach this problem right now as if there's an equal sign there. All right, so let's solve for values of x. All right, and now I'm going to go over to a number line and plot these values, -3, 0. Okay, then I will choose values to the left, in between, and to the right. All right, now you're going to plug these values into this expression. All right, and when I do, all you're concerned about is whether the value is positive or negative. In the first case, it's going to be positive. Plug -2 in here, and the result is negative. Plug 2 in here, and the result is positive. All right, so what's important about this information? I'm looking for values that will allow this expression to be greater than or equal to 0. In other words, positive values. All right, so here are where my positive values are. Here are where my positive values are. So it's all values less than or equal to -5 or greater than or equal to 0. And I shouldn't have put 5 there. That's not -5. It should be it should be 3, all right? Because these are our roots. All right, so to give you a better visual here, this is what's going on. This right here is a quadratic. So if you graph it, you should get a parabola, all right? That's my root. Coming back up, that's my other root. So what does the positive, negative refer to? It simply refers to the y values. All the y values for these points are positive, right? All the y values for these points are negative, right? So once again, I'm just concerned about the positive values. That's what I have here. So that represents my domain. All right, done. Moving on to example 5. All right, find the difference quotient and simplify your answer. All right, this looks a little crazy here. Don't worry about this h does not equal 0 part. They're just saying that h can't be equal to 0 because that would make this undefined then. All right, so be very careful with evaluating the function. Here I'm plugging I'm plugging in 5 plus h for x. So let's start this off. I'm going to have 5 times x, in this case is 5 plus h, minus x squared, which is 5 plus h squared. All right, then minus f of 5. All right, what is f of 5? I'm using brackets here because a lot of students forget to distribute that negative, which is very important. That throws a lot of students off. Watch out for that. So I have 5 times 5 minus 5 squared. All right, in the bottom I have h. All right, now simplifying everything, I have 25 plus 5h. On the top here, I'm going to have to FOIL. And since I'm doing that, I'm going to put it all in brackets. I'm going to do 5 plus h times 5 plus h. That's just a little note on top there. That's what I'm doing when I'm squaring this binomial. All right, so I'm going to have 25 plus 5h plus 5h plus h squared, and then minus 25 minus 25 all over h. Okay, what do I have now? Well, I could cancel this out here so I don't have to worry about that negative. Then I'll distribute here. And I have 25 plus 5h minus 25 minus 5h minus 5h minus h squared all over h. So 25's cancel out. Got 5h's that cancel out. Then I have negative 5h minus h squared over h. All right. Now I could factor the numerator. So I have, let's see, what do I have? Factor out an h, and I get negative 5 minus h all over h. The h's cancel out. and I'm left with negative 5 minus h. Or we typically write out the expression in descending order. So on the right, negative h, starting with the variable, then finish with the constant. And there's my answer. All right, begin the assignment at the bottom of the web page. Make sure to ask questions if you have any.